The famous American TV writer Jeffrey Steppenwolf once said, "A good fragrance is a powerful cocktail of memories and emotions." Hello everyone, I'm Diana and today I'll be talking about the chemistry behind perfume. So this is my table of contents, and in order to start, we need to know how perfumes are even created. Distillation is the process of separating the components of a liquid mixture through selective evaporation and condensation. In perfumery, it is a technique of capturing essential oil from flowers or plants using water vapor. However, not all raw materials in perfumery can be treated with distillation. There are also other methods used. Here's a picture of distilling process, which can give you a better idea of how distillation works. The question is, how does perfume smell like how it does on your skin, and how does it even last for a while? Perfumes are not new inventions but have evolved with humans. Although perfume was formulated using plants and flowers before oil was added during ancient times, it resembles how chemistry was studied and applied centuries ago. The Egyptians were famous for producing perfumes. Initially, liquid perfumes used to be a mixture of oils and crushed herbs, but then they were refined and developed. The main ingredients of a perfume are ethyl alcohol or ethanol and essential oils. A solid perfume has 20 to 30% essential oil and the remaining is ethanol. Here you can see the chemical structure for ethyl alcohol. Perfumes are made up of molecules. The size of molecules and smell are correlated because the size of molecules determine how fast they combine with oxygen, which we call oxidation. The smaller molecules, such as light citrus aroma, oxidize quickly. For instance, the musk molecule is complex and has many more electrons to give away before it disappears. The molecules of some synthetic musks are so large and complex that they can last days on your skin. Oxidation can also lead to the formation of new compounds, which may or may not contribute positively to the fragrance. The preparation of a perfume basically comprises the following components: denatured ethanol, C2H6O, fragrance, fixative, propylene glycol, C3H8O2, and distilled water, which is H2O. The fragrance, on the other hand, can be synthetic or natural. In this slide, you can see the molecular structure for light citrus aroma and musk xylem. This shows how the second one has a more complex structure, which proves that this one is going to last longer on your skin. Your body's chemistry plays a huge role in how fragrance performs on your skin. Each individual has a different body chemistry. pH level of skin also matters. The natural acidity or alkalinity of your skin changes the way a scent develops. Anything that affects your body chemistry, such as genetics, medication, hormones, and even your diet, affect the smell of a fragrance on your body. It is usually recommended to apply perfume on pulse points, because these are the locations on the body where the blood vessels are the closest to skin. The heat generated from the pulse points help to diffuse, magnify, and amplify a scent. Now, why is this even interesting? Even though perfume was widely used from ancient times until the mid-19th century, only wealthy people could afford perfumes, because the prices were dictated by their costly ingredients. All thanks to the chemists who made perfume affordable for everyone today. Today, perfumes are increasingly made using synthetic chemicals. Often, they're just scents that happen naturally and then they're reproduced synthetically rather than sourced and extracted. This helps the cost of producing perfume to go down, increasing its availability to the public. Also, the fact that the public availability of perfumes goes back to more than 2,000 years ago is interesting, because it shows how chemistry was studied and applied centuries ago. Our sense of smell is the most powerful of the five senses, so it doesn't look like perfumery is going away anytime soon. The future of perfumery depends on chemistry and its scientists to invent molecules that have never been synthesized or smelled before. If it's the perfumer's job to create a perfume using the available fragrance notes, it's up to the chemist to expand the palette of notes to be used. Thank you so much for listening.